Okay, so now we want to evaluate each of the following limits. So we're going to do a little bit of work with these to practice our limits that we know, and then in the next lesson we're going to work on proving some trig derivatives. But right now we'll just stick with some limits. So there's only two limits that we know. There's only two special limits. One of them is the limit as x approaches 0 of sine x over x equals 1, and the limit as x approaches 0 of cos x minus 1 over x equals 0. We have a couple of theorems. Those theorems are the limit as x approaches 0 of sine kx over kx equals 1. And we have a theorem that says the limit as x approaches 0 of sine kx over x must equal k. Everything else is taken from the curves and looked at directly. So let's look at this one. The limit of a sum is equal to the sum of the limits. There doesn't seem to be anything too fancy here. When I go to use property 8 and just actually property 7 and just plug in, I'll get the sine of 45 degrees, pi by 4, plus the cosine of pi by 4. Now, we should use special triangles. So off to the side, I'm going to think about special triangles for a minute. And it's pi by 4 is 45, pi by 4 is 45, 1 root 2. So sine of 45 is opposite over hypotenuse, 1 over root 2. Cos of 45 is adjacent over hypotenuse, so it's 2 root 2. That's not a bad answer, but probably if you're looking at the back of the book or anything that's published, they're going to do that to you. And so your answer is going to be 2 root 2 over 2, which is simply root 2. So I didn't need to use any of these. I just evaluated them directly using property 7. That can happen lots. Looking at this one, we got a problem. Property 8 in this case. Put 0 in for x, put in sine of 0, you get 0 over 0, indeterminate. You got some more work to do. So this looks like this one. So I'm going to try to make it that. I'm going to do whatever I can to make this look like a bunch of these so that I can evaluate them. Well, there's a bunch of different ways to do this. Why don't we divide top and bottom by x? So let's think about this for a minute. I want to divide the top by x, and I want to divide the bottom by x. This isn't the only way to do this question. Okay, so now I've got the limit of a quotient. Well, that's simply going to be the limit as x approaches 0 of 1 over sine x over x. The limit of a quotient is equal to the quotient of the limits, so it's the limit as x approaches 0 of 1 over top of the limit of sine x over x as x approaches 0. This is a constant, so that stays at 1. The bottom we know, this is one of the ones that we know, and we know that that goes to 1. So your answer is 1. Okay, over here, taking a look at this, if I allow x to approach 0, it's going to be sine of 0. It's going to be sine of 3 times 0, which is 0 over 0. So we need to do some work. Now, again, this is very familiar to some of these, and what I'd like to have is this argument here, sine of x and sine of 3x, on the bottom. Now, I'm not going to worry about getting 3x on the bottom because that's going to goof me up here, but look what happens here. If I divide top and bottom by x again, so I'm going to divide the top one by x, and I'm going to divide the bottom one by x. So it's going to be the limit of the top over top of the limit of the bottom This one is going to equal 1. We know that. The bottom one is one of our theorems. Now, if we think about it, if I want the bottom to be 3x, I'd have to multiply through by 3 over 3. That would give me a 3x here. The top 3 would be a constant, and it would come out. And so this is going to equal 3. So you're either thinking about it as this theorem here. So it's 3. And we don't have the 3 for the k, and the k is not down here, so it's just 3. Or you're thinking limit x approaches 0 sine 3x over x times 3 over 3 equals limit x approaches 0 of 3 times sine 3x over 3x. You take that 3 on the outside, 3 times the limit of 3x sine 3x over top of 3x, x approaching 0, and you can't see anything that I'm doing. So let me do it again. The limit as x approaches 0 of sine 3x over x times 3 over 3. This 3 is a constant. This 3 we use to keep here so that it matches with the top one. The 3 comes out, and it's sine 3x over 3x as x approaches 0. As x approaches 0 is the exact same as if 3x approaches 0. So this whole thing goes to 1, and you're left with 3 on the bottom. Either way, both work. Okay. Here's another example. Tan of 2x over 5x. Now what happens to tan? We haven't talked about tan. We better know what tan looks like. Do we know that tan looks like that? Or at least part of tan does? So as x approaches 0 from the right, I'm approaching 0. And as x approaches 0 from the left, the range value is approaching 0. So this is going to be 0. It's going to equal tan of 2 times 0 over top of 5 times 0, which is tan of 0 over top of 0, which is 0 over 0. Indeterminate. We have more work to do. But we haven't worked with tan. I know nothing about tan. Well, it's a good thing that I know that tan 2x is going to equal sine of 2x over cos of 2x. And that's left over from grade 11. So what I'm going to do is I'm going to change this to the limit as x approaches 0 of sine 2x over cos 2x all over 5x. Now, ladies and gentlemen, I'm going to do a little bit of algebra here. Limit as x approaches 0 of sine 2x over cos 2x divided by 1 over 5x, divided by 5x, or I can say times 1 over 5x. It means the same thing. Convince yourself of that. What that allows me to do is break this up any way I want. However, remember that these are arguments. So the 2x has to stay inside the sine, and the 2x has to stay inside the cosine. The 5 and the x are free to do whatever they want. So look what I'm going to do. It's going to be sine 2x over top of 5x times 1 over cos 2x. The 5, I think I'll move outside the limit. It's sine of 2x over x. And I'm going to take the limit to the other one as well. So now let's see what I can do. The sine of 2x over x. If that was a 2x, it would be better. So if I multiplied top by 2 and bottom by 2, the top 2 would come out, and it would leave me with a 2. So the limit of this is going to be 2. As x approaches 0, 2x will approach 0. As 2x approaches 0, cos approaches 0. What happens when theta approaches 0 for cosine? It approaches 1. So this whole thing is going to approach 1. So the whole thing is going to be 1 over 5 times 2 times 1 over 1, which is 2 over 5. This example. Again, I want to work with sine x over x, and it doesn't, there's a bunch of things here. Why don't I do this? I'm going to get a sine x times a sine x, because that's what sine x squared is, over top of an x squared, 1 plus x. Notice that I can change that to a sine x over x times a sine x over x times a 1 over 1 plus x. That whole thing to the limit. The two x's came from x squared. So it's the limit as x approaches 0 of sine x over x, which is 1, times the limit as x approaches 0 of sine x over x, which is 1, times the limit as x approaches 0 of 1 over 1 plus x, which again, as x approaches 0, is 1 over 1. So you're going to end up with that approaching 1, that approaching 1, the bottom one approaching 0. So it's going to equal 1 times 1 times 1. Okay. And the last one. Well, I see a bunch of sine x's. I'd really like them to be sine x over x's, so what I'm going to do is I'm going to divide the top by x and the bottom by x. That's going to give me on the top and on the bottom. That's going to give me on the top, on the bottom. All right, the limit of a quotient is equal to the quotient of the limit, so it's going to be the limit as x approaches 0 of 1. Subtract the limit as x approaches 0 of sine x over x, all over top of the limit as x approaches 0 of sine x over x. 1 doesn't care what happens as x approaches 0, so it'll stay 1. This whole thing goes to 1. We've proven that. This whole thing goes to 1. And the limit approaches 0. Okay, kids, I think that's about it. We went over it a little bit slower. Work through these. This is a good one. You may want to look up your double angle formulas for this one. Actually, it can be done without double angle formulas. See if you can find 2 different ways to do it. Get working on these, and we will take them up quickly on Thursday. And or maybe I'll make a video and you can look at them Wednesday night so that we can start fresh on Thursday. Okay, guys, get to work. If you have any questions, post them in the class chat.